Well, hello, guys. And I'd like to thank myself for that lovely introduction to my own video. I not sure how much it's going to help this lesson. We are going to need a lot of independent reading and study. If I'm being honest, I know the code book well. I know it well because I'm in it and I'm in it over and over. There are over 100 questions in your homework this week. And I normally think that's a little bit excessive. However, I start to wonder why I know certain code sections by heart. I want to know why I know, and I'm talking to other professionals that I work with on a daily basis. I can quote them code articles and they don't know them. They have to look them up. I know them right off the bat. And the answer is I'm in the code book more. So, as much as I was tempted to reduce the homework a little bit, I chose not to simply because this is going to be your career. You're going to be an electrician. You're going to end up in the code book a lot. And so I left the homework in there on purpose. I'm going to go through these slides. When I get through these slides, um, we can. I want you to text me, call me if you have any questions at the end. So normally, where we have more of a live situation, I am well here. I am recording this in advance to go over it. I kind of wanting to test some stuff out and uh, see if this helps anybody, anyways. If I do questions and answers at the end, and just kind of go over the whole lesson. And maybe if you have to write down some questions at the end or text questions to me at the end, it might be a little bit better. I'm gonna try. So I'm doing the video in advance. Not sure where I'm going with this, but I thought I'd play around, see if this helps anybody with the code. And other than that, I'm gonna get right into it. So we have lesson 228 coming up. Basically, articles 400 to 424. I am not going to put these in order today. These are a little bit out of order. I'm going to actually start with some motors and move forward from there. The motors math is it's not difficult. It's just, I think it needs to be explained to you. And there's a couple of homework questions about the motors and the math and the motors. So let's move forward from here. All right, we are going to define the rating, insulation, and overcurrent protection requirements for flexible cords. Location, support, grounding, and installation requirements for luminaires. Types of grounding and installation requirements for receptacles, cords, connectors, and attachment plugs. We're going to identify the branch circuit ratings, overcurrent protection, disconnect means, markings, and installation requirements for appliances. We also have general switches in Article 404. We're going to recognize characteristics of switchboards and panel boards, understand the general requirements of NEC Article 408. All right. One of the things, I know we're not going to really discuss motors this year, but this is an imperative thing for you to understand when anyone's talking about FLA and FLC. FLA is the maximum current found on motor nameplate information. FLC is the maximum current as a motor per the NEC motor tables. So I want you to think of FLC for code book and FLA for actual. We're going to get the numbers out of the code book for the C, and we're going to get the actual numbers off the motor for the A. All right, the only thing that we are going to size in motors with the nameplate is overloads. Okay, overcurrent protection and conductor sizing is out of the code book. And I say overcurrent. I shouldn't have said that. That was actually, so I digress. I should say short circuit and ground fault is going to come out of the code. Overcurrent is actually going to come out of the overloads. So I misspoke there. So read this slide here. Conductors, short circuit, and ground fault protection devices are going to come straight out of the code book. And motor nameplate is the actual. Okay, so here we go. Short circuit, ground fault protection. NEC. Motor conductors from the NEC. Overload protection from the nameplate value. Okay? So this slide is incredibly valuable for that alone. If they're asking for FLC, it's going to see C for codebook. That's going to be short circuit ground fault. Motors is going to be out of motor conductors is going to be out of the code book, and overload protection out of the nameplate. The code book tells us that when we are looking for short circuit and ground fault protection, meaning the breaker in most cases, or fuse, that is our short circuit and ground fault protection, it is sized in the NEC under these two tables, 43052C, 43052. Table 43052 will tell us that we can actually upsize that breaker by 150% to 300%. Single motor conductors are always going to be sized 125% higher than they're required, because we are going to consider them to be continuous. All right. So single motor conductors are at 125%. That is a code. That is a question in your homework. I don't know why they're throwing you motor questions when they haven't even really discussed motors, but it's in there, and I wanted to go over it with you guys. I think I'm looking at the homework right now. If we're looking at the full load current, well, they are actually going to have us do a couple of motors, aren't they? These sons of guns. They're going to have us size the amperage and the conductor based on the motor without ever us going over motors. Huh. It's amazing. All right, so motor current. When finding the motor current of rating a motor's 1 horsepower is considered to be 746 watts. This is only true for motors that are 100% efficient, and therefore we can use this formula. Motor horsepower, voltage, and efficiency, and power factor have to be known. I wonder if I can. Let me try this. I sure can. So here's my formula. My nameplate amps is going to end up 746 times the amount of horsepower over the voltage times the efficiency times the power factor. And that's how they come up with it, just so you're aware. Okay, so this is the stuff that they're going to do in your homework. And again, if you've got questions, write them down. Wait till the end. I will get back to them. All right, what's the full load current of a 2 horsepower, 240 volt single phase motor? Okay, so I am going to go. Let me look at the table. I'm going to go to my table for my single phase motors. single phase AC motors. That is table 430.248. I highlight that. Next year you're going to use this. They've moved motors to next year. 430.248, I highlight that table. I go to the next page over to the right, 430.250, and I highlight that table. It may not matter a whole lot this year because our code book's changing, but I would certainly highlight it if you have the 23 code book and you're going to be in school, in the class next year. All right, basically what I'm going to do is I'm getting the FLC, the code book, the full load code book answer. For a 2 horsepower motor at 230 volts, right out of the table, I'm at 12. Okay? I'm going to take that number 12. Oh, I'm ahead of myself. I'm just showing you how to use the table first, so I apologize. So that's how you get there, 12. There's more steps to this. Okay, according to Article 432.50, what's the full load C code book for a 10 horsepower 208 3-phase motor? Okay, so now again I'm on table 432.50. My horsepower is 10. I go over to 208. I'm at 30.8. So that's the FLC code book for that motor. All right, another FLC example. According to table 432.50, so again 3-phase, what is the FLC for a 20 horsepower 230 volt 3-phase motor? Here we are. 20 horsepower, 230 volt, 54. Okay, pretty easy table to use. So, now we know what the FLC is. We can use it to determine a couple of different things. I can use it to determine my conductor size, and I can use it to determine my ground fault and short circuit. Okay? So the motor branch circuit is the point from the last fuse or circuit breaker protecting the motor circuit out to the motor. Article 430.22 requires that branch circuit conductor supplying a single motor used in continuous duty application shall have an ampacity of not less than 125% of the full load current rating. Okay? So that means if I have a continuous duty application, which almost all your answers are going to have to be this 125, I don't care if it's this or your journeyman's test or where you're at. I've always seen them add the continuous duty 125% for conductors. So we're going to take that FLC number and we're going to multiply it by 125%, and that's how we're going to size our conductors. It's really that simple. So here we go. What size conductors are required for a 1 horsepower single phase 115 volt motor? Okay, so I'm going to go to single phase. So now I'm at table 432.45, right? I go to 115 volt motor. I go to 1 horsepower. It tells me I'm at 16. Okay. So now at 16, I multiply 16 by 1.25. And that's going to give me 20 amps. I'm going to go back to table 310.16. I'm going to look to see what 20 amps is required to be. And it's 12 gauge. And that's how I determine conductor size for a motor. It's literally that simple. I take the FLC, I multiply it by 125%. Okay. Another example for conductors. Let's look here. We have, what size conductors are required for a 5 horsepower single phase 208 volt motor? Okay, so I'm going to go to a single phase 208 volt motor. I'm going to take my time here, let you guys take a peek in your books, see which table you want to use for a single phase 208 volt. I hope that you guys landed on 430.245. All right. In doing so, a 5 horsepower motor, 208 volts. Looks like 30.8 is my FLC, right? So 30.8 times 1.25 equals 38.5 amps. Then I'm going to go to table 31016. Let me find it. There we go. Table 31016. I have 38.5 amps. I look to see what conductor in table 31016 in the 75-degree column, assuming copper, I can use. Oh, I'm in the 60-degree column here, aren't I? So, conductors for a single motor in a continuous duty application size at 125% of the FLC, 30.8 times 125% is 38.5. 8 gauge, rated at 40 amps at 60 degrees Celsius. Okay. Eight gauge in the 60 degrees Celsius. I am not sure. Okay. What size conductors are required for a 5 horsepower 208 volt motor? And what's going on here is, if you're in table 31016 and you look at number 18 gauge through 10 gauge, and you look at the asterisk next to them, it's going to take you to 240.4D, and it's going to give you the small conductor rule, telling me that I can't use a 10 gauge conductor in the 75-degree column. That's the only reason I can see why they're using this 60-degree column for this number 8. Must be the small conductor rule. So they tricked me. All right. Conductor size for continuous duty example number 3. What size conductors are required for a 5 horsepower single phase 230 volt motor with terminals rated at 75 degrees? Okay. So, conductor size for continuous duty example number 3. What size conductors are required for a 5 horsepower single phase 230 volt motor with terminals rated at 75 degrees? So I will go to 43248 for a single phase motor. I roll down to 5 horsepower. I look under the 230 volt category and I see 28, right? So I'm at 28. I multiply that by 1.25. And what does that give me? 28 times 1.25 is equal to 35. Oops, 35. So now I know 35 is my magic number. I'm going to run over to table 31016 in the 75 degree column. And I should be able to put number 10s on there, right? Number 10s in the 75 degree column for 75 degree rated terminals. 75 degrees, so a number 10. Okay. All right, so here's another example. In this example, this is a 22 amp. $125 ends up with 28 amps. So at 28 amps, you could use the 60 degrees Celsius table for a number 10 as well, if you're in the 60 degree column. Okay, and I believe, let me double check. The homework says, I'm looking at 228.1, refer to the nameplate shown in figure 230.128. The branch circuit of the motor is supplied from a 120 240 volt three-phase four-wire panel board. What's the minimum size ground wire plus STO cord that can be used as a flexible connector to the motor? Well, that's kind of a lot, you know, for just sitting here doing reading. I don't know how fair that homework question is. So let's just take a peek at that homework question. I'm going to undo this. And we'll go here. So our homework question number 228.1. Refer to the nameplate in 230.128. The branch circuit for the motor is supplied from a 120 240 three-phase four-wire panel board. Well, why in the heck would I care about the nameplate if I'm looking for the conductor size? It's a trick. They're being jerks. Right? So I have to figure out a 120 240 volt three-phase four-wire panel board. So what am I going to do with this guy? I'm going to take my table full load amps, my full load FLC out of the code book, right? And which table am I going to use? I'm going to use 43250, right? Because it's three-phase, four-wire. I'm going to flip over to 43250. Sorry, I keep flipping pages, so it's taking me a second here. I got two books open on my lap. So this is a 15 horsepower. And we're going to do what? 230 volts. 15 horsepower, three-phase at 240 volts. I see 42 at 230 volts and 21 at 460 volts. If I were to go 460, I'd point out that it's 21, but I want you to see that we're actually going to be pulling 42 because it's 230 volts and not the 21. So even though the motor's rated to go higher, the panel feeding it is not. So 42 times 125 is where I'm going to go with that. So 42 amps is my FLC. Okay? And I got that out of table 43250. And I got that by using the 230 volt portion of that table. Okay. So to get my conductor size, I simply take my 42, I multiply it by 125, or 1.25, sorry. And I end up with 52.5. Okay? 52.5 or 53 amps or 4 gauge wire. Okay, there we go. So that's 228.1. I thought that was kind of tricky, so I went ahead and just did it on the fly. Not really planning on that, so I apologize for the last minute substitution, but let's just go ahead and do the other ones too, because I don't think they're being very nice to us here. So let's look at 228.1 number 2. That last question was 228.1 number 1. All right, so 228.1 number 2 says for this motor in scenario 430.28, the minimum size SO cord permitted contains blank AWG conductors. Oh, I forgot on that last one, the SO cord table. I completely forgot about doing SO cord with you guys. So I'm going to get to that. And SO cord has its own tables. These things are not, where are they at? They're in 400. There we go. 400, Article 400, Table 400.4 is flexible cords and cables. Okay, so this is part of Article 400. So not only are they throwing motors at us, they're also throwing SO cord. These guys are just jerks this week. I'm not into this. I don't find this fair or fun. So we'll do this one together as well, because I don't think it's fair or fun. But you will need to know how to do this. So number 2. So let's go through it. I'll take a little more time on the conductor on this one. It looks like I have a 5 horsepower, 208, 230, 460 volt 3-phase. Fed from a 3-pole breaker and a 120, 208 3-phase 4-wire panel board. So it's 5 horsepower, 208 volts. That means I'm going to go over to table 430, 250. I'm looking at 5 horsepower, 208 volts. And I get 16.7 amps, right? So 430, 250. I just said I have 16.7 amps. That's my FLC. I multiplied that by 1.25. To get my conductor sizing, and I need a conductor that's going to be sized for 20.9 amps. Okay, so I'm going to have to go to table 400.5 A1. So let's all go to table 400.5 in our code books. 400. Did I give you the wrong table? Nope, I didn't. 400.5 A1. I'm going to look at the conductor size or type that they gave me for SO cord. And it looks like it's going to fit there. On the SO cord type, I'm going to pull down to find out what I need. I have 20.9. That gives me 12. Or no, 11, I'm sorry. 11 gauge. For 20.9. That pushes me up to the next size up, right? Column A and column B is of note on this table. If you look at column A, there's a little note that says A1 and B2. Okay? So under the bottom of the table notes, it says the currents under column A apply to 3 conductor cords or multi-conductor cords connected to utilization equipment so that the 3 conductors are current carrying. The conductors under column B are 2 conductor cords and other multi-conductor cords connected to utilization equipment so that only 2 conductors are current carrying. So that's the difference between column A and column B. So at 20.9, the answer here is 11 gauge. Or D. For 228.1 number 2, the answer is D. Okay, guys, so here we are. 228.1 number 3. The nameplate for a 15 horsepower 3-phase motor shows an FLA of 18 amps at 4600 volts. What minimum size SOO cord is required to connect the motor to the branch circuit? So again, they got us going to table 430, 250 for a 3-phase motor, 15 horsepower. If you look that up, you're going to find that it's 21 amps. So we're going to take our 21 amps, my FLC, multiply it by 1.25. So they keep giving you this motor nameplate rating, knowing that you do not even need it. So didn't think it was fair. Thought I'd go over these with you. 21 times 1.25 ends up at 26.25 amps. And then if you go over to 400.5 table A1, column A1, you will see that the proper size of SOO cord is going to be 9 gauge. Okay. Those were ones I definitely wanted to go over with you guys. Just one more here. We can clean this up a little bit. So you can see where we're at here. We're taking the FLC, multiplying it by 125% to get an amperage. And then we're going to the appropriate table. Either if they're asking for SO cord, we're going to go to the table for SO cord. If they're asking for a normal conductor, we go to 31016. It's really just that easy. All right. Flexible cords and cables contain 2 or more insulated conductors and is suitable for its intended use and location. Okay, so there's some things that we cannot do. We cannot feed a we cannot use a cord or cable to feed a sub panel. I had a guy try to do that in a residence once. That did not make his day, showing him that code article. Flexible cords and cables and power supply cords are not permitted as substitute for flexible fixed wiring. We are not allowed to put cords above suspended ceilings. You see this all the time. This is something that, as an inspector, I failed a lot. At bars, dentist's office, they'll put TVs up in the corner. I mean, just about every place. People use it for show window lighting, outlets, things of that nature. That's 400.12. So this picture is a violation, and you see it all the time. But you are not allowed to do that. Okay. Housing shield hood over a faceplate for flush-mounted wiring device or an integral component of an outlet box, or a faceplate for flush-mounted wiring devices commonly known as a bubble cover, is required per 406.2. 406.3D for receptacle terminations. This is a new code change. This is new in the 2023. We are now going to have to start dealing with 14 gauge copper conductors. So you're going to see a lot of 14 gauge stuff come in, or not 14 gauge, 10 gauge copper conductors, as well as this. So this is a prelude to the push-in type terminations only for 14 gauge, because 10 gauge wire is coming down the road. 10 amp wire is coming down the road. It's going to be legal in the 2023 code cycle, and they're very particular on what you can and cannot connect to 10 gauge conductors. So this is all part of cleaning up that 406.3, basically saying you're only able to do push-in type connections with 14 gauge now on receptacle terminations. No more can you do with 12. These are the push-in type. This is the image of the push-in type connect terminals right here. All right, isolated ground receptacles, triangle orange. So you got the green triangle. Normally these are orange. You could also have a orange triangle. And what that means is you have a dedicated, isolated equipment ground, I should say. So I have a ground that's bonded to the metal in the box. It's bonded to the pipe. It's bonded to the sub panel. It goes everywhere. This isolated equipment ground, it goes straight back to the panel, and it doesn't have to bond it to anything. And the reason they do that is for sensitive electronic equipment. It keeps the noise, if you will, off the ground. It keeps all the stray voltage that the bond might contain. It keeps it all off there, and it's a clean ground for computer equipment or sensitive equipment. Okay, isolated ground receptacles. You know what? Let me try to. There we go. I had these a little blown up. I apologize for that. Okay, the equipment ground for the yoke must be contacted to the insulated equipment grounding conductor. So the regular ground is touching the yoke. Isolated ground receptacles. The grounding contact must be connected to an insulated equipment grounding conductor for per 250-146D. So this is a separate isolated ground. So it's going to have a bond through this yoke going to these screws. And then it's going to have this insulated and isolated ground going all the way back to the panel, wherever that is. And it's not going to tie into the other grounds, and it's not going to tie to the bonds. It's going to get its bonding and grounding through the yoke. And this conductor, the separate conductor, is going to handle the clean power, the clean ground back. 400.6a is receptacle installation of grounding type receptacles. You can do this through a couple of different ways. You can run this bonding jumper, like you see here, to the box and over. But if it is a self-grounding type yoke, see this little copper yellow guy on the bottom here? If it is a self-grounding or listed as a self-grounding type yoke, you do not need this grounding jumper to go back to the box. The screw, if you use the factory screw or a 632 with at least 2 threads in the metal, it will count as bonding your screw, as bonding your receptacle. All right, this is a hot one actually. Replacing non-grounding type receptacles. No equipment grounding conductor at outlet box. So in older houses, especially older Denver, older Aurora, older everywhere, non-grounding type receptacles can be replaced with a GFCI type receptacle if the receptacle of the cover plate is marked no equipment ground. Okay? So you have a choice. You can use a GFI that says no equipment ground, or you could put in a 2-prong plug back in its place. I personally would prefer the GFI if it was my house, because the GFI is going to at least offer some protection from it's going to be able to detect ground faults even without a ground. So if more power leaves the hot conductor than returns on the neutral conductor by a factor of 0.035 milliamps, the GFI will trip off. You can use this for your sensitive appliances in older homes, and your TV, your computer, stuff like that. It's going to be a heck of a lot better. Because if you plug in a surge protector to this, it's going to be useless. That third prong on the surge protector isn't going to actually surge to anywhere because there's no ground. So a surge protector in an old 2-wire system is useless. At least a class 3 surge protector, the normal strips that you're dealing with. Replacing non-grounding type receptacles or no equipment grounding conductor at box. So here we go. You could put a GFI in as a breaker as well. You could put a GFI in the wall. Both have to be marked as no equipment ground. All right, 406.4D8, ground fault protection of equipment. GFPE requires ground fault protection from equipment and/or what we would call a Class B GFI to be provided for replacement receptacles that require Class G FPE protection by requirements found elsewhere in this code. So if you have a Class B GFI for equipment that you're replacing, the new code applies to receptacles that you're replacing, is basically what this is about. If you have one of those situations, you have to upgrade to the current code. Here's an example. A dock, 30 milliamp for protection of equipment. The difference for personnel is 4 to 6 milliamps. Okay, so the Class B GFI, 30 milliamp for equipment. Class A GFI, 4 to 6 milliamps allowed in the code. That's for people. Okay, 406.5G1 receptacles cannot be installed in the face-up position in countertops. The new code again, and all these new ones you see with this 406.6 receptacle faceplate with integral night lights are now going to be acceptable inside the code. So this was a code change in 406 for this 2023 cycle. And this is an image of that. But you can only do it with a load that is 1 watt or less. All right, attachments, plugs cannot have energized parts. Okay, so I cannot have a male-to-male connection per the code 406.7. I can't have a bunch of metal prongs that are hot laying around someone could step on, touch, or otherwise hurt themselves or someone else with. That is a code violation. Flange surface inlets. A flange surface inlet must be installed so the prongs or blades or pins are not energized unless an energized cord or connector is inserted into it. So this cannot be hot and then I plug a female into it. The female has to be hot to charge this male prongs. 406.7. Another code change is it's actually a pretty good significant positive thing, is a 406.9 bathtub and shower space has been clarified. So in the previous code, it didn't mention anything below the rim of the hot tub. So I could literally put, or bathtub, I could literally put an outlet just below the bathtub water level 2 inches away and it was totally okay. They've cleaned up the language that now there's an entire bathtub and shower space that's been identified, and that's 3 feet by 8 feet. There's some exceptions about when you can add an outlet. You could do a single GFCI protected outlet for a bidet or something of that nature. Again, a single receptacle only in that space. All right, 406.12. This was hot several years ago. It's old hat now, but 406.12 is your tamper-resistant receptacles and where they're required. So if you want to find out where those are required, you're going to go to 406.12. The 2023 code has, of course, added things. Every year we add things to that list. Text for clinics, medical, dental office, and outpatient facilities. Anywhere that's accessible to the general public now has to be tamper-resistant receptacles. This is going to go the way of the GFI, and I'm saying pretty much everywhere is going to need them soon, but that's just a guess. And you can see the TR in a tamper-resistant receptacle notated with the TR. If it's outdoor rated, it's going to have a W there, a WTR for weather resistant, UV resistant. So technically you could not put this in a bubble cover and stick it outside because it's not a weather resistant, tamper resistant plug. All right, switches. 404 apply to all switches. Now, when we think of switches, most of the time we think of the wall switches that you use in your house, the toggle switches. Circuit breaker and overcurrent devices can be considered switches. They just are automatic switches. So, a mechanical mechanism that manually or automatically opens a circuit when overloaded condition, ground fault, or short circuit occurs. Switch is a device with a current and voltage rating used to open or close an electrical circuit. So things we wouldn't normally consider switches are definitely switches. Old fuses, breakers, things of that nature. There is 2023 code change 404.1 addresses wall-mounted control devices. Battery-powered wireless wall control devices are new technology and guidance was needed, so how we can install them. 404 does not cover wireless control switches that do not connect to electrical branch circuits. The informational note directs the user to code section 210.70 for lighting outlets required. So we're starting to get into these battery-mounted switches for code purposes. This is what they're looking like. I can control multiple lights from one location, things of that nature. And so the code's starting to address some of this stuff. 404.2, switch connections. Basically telling you that you have to have a neutral at most locations in habitable rooms or occupiable spaces. So there's some spaces that you do not need them. Unfinished basement, you wouldn't need a neutral down there. It's an uninhabitable room. It's not considered a habitable or occupiable space. Now, what I'm catching on to this, and I don't know because I don't have my code book open, but 404.2c, I'm seeing defined in the building code. Habitable rooms or occupiable spaces. But this is strange to me. I don't remember this wording because the building code would be the IBC. So we'll have to clarify that if you guys want to. I'll try to look into that a little bit later after class. See if I get you guys some answers. 404.2a, by providing the return conductor in the same ferrous raceway as the switch conductor, inductive heating effects can be minimized. 404.2, switching of grounding conductor is prohibited. So the grounded conductor, so you cannot switch a neutral. No California three-ways, no Milwaukee three-ways. 404.2c tells us when neutral conductors are required to be installed at a switch location. So 3- and 4-way switches controlling lighting loads in habitable rooms or occupiable spaces, you have to have a neutral. So if you'll look at these red ones, the dining room is not considered habitable. Nope, it is. Bedroom, it is. This kitchen receptacle is interesting because if there's the exception. If both switches are are visible one from another, you do not need a neutral at both boxes. Now, if this switch was on the other side of the wall in this kitchen, this blue one, you would need a neutral at both switches. And that's what they're showing you here with living rooms. The garage is not a habitable space. The bathroom is not a habitable space. The closet is not a habitable space, so you don't need neutrals at those locations either. All right, a neutral conductor is not required where conductors enter the box, enclosing the switch through a raceway with sufficient cross-sectional area to accommodate adding a neutral conductor. So if I have EMT and I have a way to get a neutral down later if I need it, I also do not need a neutral at that location. A neutral is also not required where the box enclosing a switch can be accessed to add or replace a cable without damaging the building finish. Switches controlling receptacles 404.2C5. A neutral conductor is not required for lighting I apologize. A neutral conductor is not required for a lighting switch location where the switch controls a receptacle. The slide is written wrong. That's half my problem here. The whole point is you don't need a neutral at this switch because you're just switching a half hot. Not really a big deal. You're also not allowed to have a dimmer there. We don't want to put your vacuum on a dimmer. If not already present, a neutral conductor must be installed for any replacement switch that requires a neutral to line to neutral voltage and operate by the electronics of the switch in standby mode. So if you put a motion detector in there and it requires a neutral, technically you're not supposed to be using the ground, because that would be a violation of 250.6. Objectionable current. We do not want objectionable current on our grounding conductor. All right, I think we touched on this a little bit earlier in the year. We talked about L bends and S bends, so I'm not going to get too far into it. 404.3 talks about L bends. 312.6a talks about S bends coming in the opposite wall. So basically, 404.3 is simply pointing us to those code sections, saying that there has to be adequate room. Apologize. Had that one kind of messed up. All right, switches must indicate whether they're in the open or closed position. When operated vertically, the up position handle shall be the closed position. All right. So you shouldn't really be replacing or putting in a three-way switch with no indicator, and especially not upside down. So there is a code article, 404.7. All right, circuit breakers used to switch 120 volt or 277 fluorescent lighting circuits must be listed and marked for SWD or HID. Those used to switch high-intensity discharge lighting circuits must be listed and marked as HID breakers or SWD breakers. 404.8 tells us about accessibility and grouping. All switches and circuit breakers used as switches shall be installed so they can be operated from a readily accessible location. This is a big one. The center of the grip of the operating handle when in the highest position shall not be more than 6'7" above the floor or working platform. All right, anytime that you have 300 volts between circuits, if you have, in this instance, a 277 volt circuit out of your one transformer and 120 out of the other, you are required to have a barrier when you exceed 300 volts between adjacent devices. So if you exceed 300 volts, you're to put a barrier in these boxes. .9b1, the use of metal screws to attach the switch to a metal box or cover that is connected to an EGC, or the use of an EGC to directly connect to the grounding terminal. Kind of already touched on this one too. We talked about it for receptacles, but now we're going to talk about it with switches. So if you look at this little switch in the diagram over here, this is what I call an industrial cover. is actually not rated to carry a ground. Those 1024s that they have that go on each corner of that box, the threads are too large. There is not two threads touching, so those industrial covers need a pigtail back to the box. All right, machine thread screws engaging so many threads provide reliable continuity. So this is what I was talking about. Those 1024 threaded screws on the industrial covers are too far apart, and they do not have two threads inside the metal, and that's why they have to have that ground. Switch grounding metal boxes says the switch is connected to an effective ground fault current path when the yoke is mounted with the metal screws to a metal box. So if you put a drywall screw in there, it doesn't count. You definitely need a yoke if you did a drywall screw. And if you did a drywall screw, technically you should probably fail for not using the correct screw with the correct device, but just food for thought. Switch to grounding non-metallic boxes. The grounding terminal of the switch or yoke must be connected to the circuit equipment grounding inductor. So if you're using plastic boxes, you don't get a choice. You have to connect this ground. This is the violation I'm talking about. These threads are too thick. They cannot make it. Two threads will not be in contact at the same time with that box, so it's too far. Too far apart, not enough solid contact with the box. You have affected the low impedance ground fault. This is the high impedance ground fault path now. So, right here, it must be machine screw having 32 threads per inch or part of a listed assembly per the manufacturer's instructions. So, a 632, an 832, that's why the 1024 doesn't work. It's got 24 threads instead of 32. Snap switch terminations. There's some new language in the 23 code. Solid copper conductors used with snap switches resulted in section entitled Snap Switch Terminations. Highlights the limitation for switches to provide push-in terminals. So we're back to this 14 gauge thing. Like I said, you're going to see this because we are now allowing 10 amp circuits. They're going to start coming down on these devices a little bit more. Here's the push-in terminals of the switch, just like the receptacles we saw earlier. 404.30, switch enclosures with doors. Switches of this type may allow access to live parts when the doors open. Access to an interior of a switch in the closed position will now require the use of a tool. An appropriate design providing equivalent protection is also allowed. Or an example of a product that might be approved is the Eaton brand switch that requires simultaneous movement of two hands placed in different positions and acting against resistance in order to open. Okay, so there's a couple of ways to do this, but from now on, our little one-arm bandits and stuff, they're going to require the use of a tool to open them. Especially if they allow access to live parts. That's the point of that one. Okay. Yeah, I guess I already touched on this. A dimmer receptacle isn't listed to control a receptacle. A dimmer is not listed to control a receptacle. You don't want a dimmer on your TV. You don't want a dimmer on your vacuum. You cannot dim a switched outlet, technically. I know people do it with rope light, or they used to. Should not be doing that. Okay, so new article 408, switchgear and panel boards. In 2023, this is a new article. There's been some changes to a couple of things. I think they're all actually real positive. in the 2023. Switchboards are different from panel boards in that they can be freestanding and have rear access and have rack out capabilities. Pardon me. So you'll see in this picture that this is a switchboard, not a panel board. That rear access is important for lacing and bracing. There's all kinds of stuff. And I don't know how many of you guys have worked in a area where there's a big switchboard or medium voltage gear. You'll see, if you see the red arrows on this stuff, it actually shows you which way the bus is arranged all the way around and which section feeds the other section. So I don't know if you guys have ever seen that, but that's incredibly helpful, especially when you're first taking a look at it and you're not sure what's going on. As an inspector, when I walk into something like this and I see all this gear, it's overwhelming until you start taking it piece by piece, and then you start saying, okay, well, this breaker comes down here and feeds over, and I can follow the red line. All right, this one feeds this one feeds this. And it makes it pretty straightforward. So large ampere or medium voltage breakers are often in switchboards enclosures that have remote racking capabilities for increased safety measures. Got a little extra distance. It goes without saying. Increased safety measures. Power circuit breakers are equipped for high-speed stored energy operating mechanisms. They are designed with several built-in interlocks and safety features to provide safe and proper operation sequence. There's some of these breakers that you have to actually charge so that when it turns on, it's almost like a wind-up jack-in-the-box in a way. It's the best way to describe it. So you've literally got to sit there and mechanically push up and down on these breakers, and you're tightening a spring, and then when you flip the thing on, it slams forward and makes an instant connection. And the reason for that is if a person real slowly flipped the breaker up and you've got 14,000 volts going to it, you're going to have a real big arcing issue. So that's kind of some of the things that we're talking about that's different in switchboards. A little bit more complex, lot more expensive. All right. 408.3E is about the bus arrangement. AC phase arrangement on three-phase buses shall be A, B, C from front to back, top to bottom, or left to right, as viewed from the front of the switchboard, switchgear, or panel board. So that is absolutely going to be a homework question, and probably almost certainly going to be a question on your final as well. This question comes up all the time with IEC materials. .408.4a is the field identification, circuit directory, and circuit identification. There was a little bit of change in this in the 23 too, to remove some ambiguous language, but not a major change. All circuits and circuit modifications must be legibly marked with an approved amount of detail to allow each circuit to be distinguished from all others. So general lights and general plugs does not really cut it, does it? So sorry about that. Spare provisions that contain unused overcurrent devices must be described as spare. Okay, we can't have those sitting in there unidentified. I know I'm guilty as everybody else. I'm in a hurry. I want to get through some stuff, especially with residential stuff. I I always just figure, I don't need to label this. I'll just put it as general or label one thing on the whole circuit. But it does matter especially to the homeowner. But yeah, I don't walk on water. I'm super guilty of just writing vague descriptions and moving on like I said, especially residential panels. So 408.4 is a 23 change. The requirements for circuit directories and descriptions were placed in a list format for clarification. There was some confusion with the previous text as written in the paragraph form. Information in a list format is easier to understand. It's not always readily apparent where the source is located, and this will clarify labeling and descriptions for panel boards and panels for the electrical professional as well as the end user. I mean, that's the intent. But we all know when I'm in a hurry, I'm just still going to write general lights and plugs, right? I'm just kidding. I'm gonna be perfect every time. I can always improve, right? Requirements for circuit directories and descriptions were placed in a list format for clarity. And again, here's a good example. You can't put Jody's room, Fred's room, and Dave's room because when I buy your house, I don't know who those people are. Circuit and circuit modification required to be legibly identified as to its specific purpose or use. Identification should appear in the circuit directory. So you can have a detailed circuit directory as a separate book if you'd like. That'd be a great idea for most homeowners. Okay, replacement panel boards. There are now 2 list items for the replacements of existing panel boards in an enclosure or cabinet. A, if a panel board is listed for the specific enclosure type, the replacement panel board shall be allowed to remain in its short circuit current rating. This can be determined by the catalog number and other dimensional information. B, if the replacement panel board is not listed for the enclosure and the available fault current is greater than 10K, the installation is to be field labeled, meaning we need to get a nationally recognized testing lab out to take a look at it and see what's going on. The replacement panel board is to be identified for the application if the available fault current is 10,000 amps or less. If the cabinet has previous listed markings pertaining to the previous panel board, the listing markings are to be removed. So here we go. This is what we're talking about. You can see that the cabinet with the yellow sticker has one listing and the panel board has another. All right, so it's becoming more and more popular, especially with these indoor panels, to just replace what we call the guts, which the code calls the panel board. And that panel board is going to have the same short circuit current rating, right? So the panel board is identified for the application if the available fault current is less than 10,000. If the cabinet has any previous listed markings pertaining to the previous panel board, the listing mark is to be removed. All right. So spaces and clearances. This was a little bit of a change in the 23 as well. So 408.18 clearances. A space of not less than 3 feet shall be provided with the top of a switchboard or switchgear and a combustible ceiling. This is not required if a non-combustible shield is provided between the switchboard or switchgear or the ceiling and the ceiling, I apologize. Or if the switchboard or switchgear is of the totally enclosed type. So if it's totally enclosed, not really a big deal. I've seen open ones, but most of the open ones I've seen are DC switchboards and panel gear. I haven't seen any AC type that are open in the top, but I'm sure they exist. Just because I haven't seen them doesn't mean they don't exist. All right, 408.36, overcurrent protection. Protection must be provided for each panel board using an overcurrent protective device that does not exceed the rating of the panel board. Look at that cover. That looks homemade, doesn't it? So per 408.36, the location of this overcurrent protection device is to be within or at any point on the supply side of the panel board. Okay, so we are required to have overcurrent protection for a panel board somewhere, right? I mean, we're going to either have it at the main, we're going to have it at the panel board, maybe both. So another change for 23, 408.38, enclosures, panel boards. The panel board enclosure combination shall be evaluated at the application for the application where the panel board is installed. A cabinet, cutout box, or identified enclosure and has an available fault current greater than 10,000 amps. This is what we're going to concern ourselves with. The cabinets are the common enclosure for the panel board, but they are being installed in other types of enclosures. When an existing panel board needs to be replaced, and the cabinet or other enclosure is installed in a block wall, this can be problematic. The new requirement for the application will be evaluated where the available fault current is greater than 10K. It will provide guidance and a workable solution for these instances. An exception exists for equipment without a dead front and maintained by a qualified person. Right? So here we go. Our 23 change. These shall be evaluated for the application when the panel board is installed in a cabinet, cutout box, or identified enclosure and having an available fault current of 10K or more. All right. Cabinets are the common enclosure for panel boards, but they are being installed in other types of enclosures. Okay. Make sense? Pretty straightforward. This is a code change, not going to be in your homework, just something we throw in there for you guys to see the code changes. Here's a code change. In addition to not being able to be installed face up, panel boards now in 2023 cannot be installed in the face down position. So 408.43. So even with acceptable working space, you cannot put a panel in the face down position. There's a good example. Jazzy Jennifer says, it would be very difficult for a qualified worker to work safely when lying, kneeling, and standing on the floor looking up at the components of the panel board. Yeah, even with 3 feet, now your entire body is touching the ground. I think it's a bad idea. I kind of like this code change. I'm all for this. It's kind of hard to believe that it was ever legal. I don't know when I would want a panel that way, but I'm sure there's a couple of times. Either way, Engineer Nick is about to experience an arc blast, and that ain't good for him. I mean, I guess it saves space. Look at this. Panel boards cannot be installed in the face down position. Look at all the room that saves. Anyway, obviously we are not allowed to do it. Okay, luminaires. There's a lot of questions about luminaires in the homework this week. Luminaire specific locations for bathtub shower areas, 410.10 D1. You see how this shower area does not extend below the bathtub water level? That, again, is a 2023 change. They did fix that. So that now extends all the way to the floor. But specific to luminaires, 410.10 says no part of a chain, cable, or cord, suspended luminaire, track luminaire, pennant, or ceiling paddle fan is permitted within the bathtub shower threshold. All right. Recessed and surface-mounted luminaires are okay in that area, but they must be marked for damp locations or marked suitable for wet locations. Luminaires are subject to shower spray and must be marked suitable if they're in the shower for wet locations, right? Closed closet luminaires. We can't use this keyless. This keyless light is a violation. Incandescent and pendant type luminaires are not permitted in closed closets. Doesn't take a lot of thought to see what would happen if that hot light bulb burst on that, what I'm assuming is a cotton blanket right there. It's a great example. All right, luminaires in closed closets, installation surface mounted, 12 inches from closed closet storage spaces. If you have a fluorescent, it needs to be 6 inches away, minimum. So a lot of times there's like a misnomer out there. I don't know what it is, but I'll run into guys, especially newer guys, that say, oh, I got an LED, I can put it anywhere in the closet I want. That's not true. Or I got a fluorescent, I can put it anywhere in the closet I want. That's not true. You can't stick it directly over a closed closet storage space for a fluorescent light. Recessed light also needs to be 6 inches away. Right? So even though I got a recessed light with a LED bulb and a shower trim, I don't care. It needs to be 6 inches away from the closed closet storage space. We don't want that thing breaking and then showering down onto clothes. Now, will that make the difference? Most closets I go into, I don't know. If there's not stuff piled on the floor or clothes that are going to stick out everywhere, I don't know. But it's an attempt. We're going to try not to burn down houses if we can. Okay, now, as I misspoke earlier with the LEDs, they are permitted within the closed closet storage space. But here's the kicker. They have to be identified for such use. So you can't just stick any LED fixture in there and think that it's good. So if you have an inspector who knows what he's talking about, and you say, oh, I got an LED in there and it's inside the closed closet storage space, no big deal, and he asks you to see the evidence that it's identified for that use, you might have a difficult time finding it. So, food for thought, especially when you're roughing a house. You don't know what they're going to be installing. It might be worth it for you to bring those things out 6 inches. All right. Outlet boxes are to be covered. So this is not so much a thing anymore, but I've installed a ton of track light and taken down a ton of track light. Outlet boxes for luminaires must be covered with a luminaire canopy lamp holder receptacle that covers the box or is provided with a faceplate or similar device. So you can see this track light has to cover the wiring. Can't have exposed wiring when you're doing a track light. All right. Luminaires. Equipment grounding conductor. All the metal parts of a luminaire must be connected to an equipment grounding conductor of a type recognized in Article 250.118. All right, so we want to maintain that low impedance path back to ground. We're going to do that with this. We have a short circuit to this light. We want a low impedance path back to ground. Again, there's a ton of luminaire questions in your homework. There's a whole section on this, so you might as well dig into 410 Okay, 41010F, luminaires are installed in or under roof decking. Requires 38 millimeter or 1.5 inches to luminaires under any roof system where physical damage can occur to luminaire. So roofers installing screws and other fasteners occasionally miss trusses and rafters and could inadvertently damage luminaires. So now, if we are going to be putting lights in for roof decking, we have to have 1.5 inches. Okay, so our commercial tenant finishes, and we slap those lights up there, they need to be 1.5 inches down below the roof decking. The exception, though, utilizing concrete does not require the 1.5 inch space. Right, here's a good example. I do not have 1.5 inches from the roof decking down. So they just stuck a piece of unistrut up there above the joist, put the light there. 1.5 inch screw could hit that ballast or light or portion of that light. Or a long screw from, I would say, 1.5 inches. A long roof deck screw could hit and damage that light, cause problems. All right. Okay, so in this one, you could actually see some of the screws sticking down. You can see how far those things protrude. They're pretty long. And they can easily hit these lights. So probably a positive, good code change. All right, 41071, disconnecting means for fluorescent or LED luminaires. This is basically relocated the requirement for disconnects for luminaires to this location because LED drivers were added to the section. So really this code change is not really a change, it's more of a relocation. All right, here's our disconnects for luminaires. This counts for fluorescents or LEDs. Okay. Germicidal irradiation. We now have in the 23 code, Article 410, Part 17. Germicidal irradiation has been used to disinfect air, water, and surfaces for many years, but I guess COVID-19 must have brought this about. Germicidal irradiation for luminaires are to be listed, and I know nothing about this. So this is just a code change that you need to be aware of, I suppose, that it's in there. But they're using it to kill bugs, purify air, and purify water. Now, I've actually seen this for water, now that I say that. I've seen them use some lighting inside water to keep algae from growing. Now that I say this out loud. So, okay, so there's an entire code article to address this now. Here's an image of, I'm not sure that's germicidal, but maybe so. Pretty neat either way. I guess it is. Don't know. Kind of a new one on me. Germicidal irradiation. All right. In 410.184, GFCI protection and SPGFCI protection. Okay. Special purpose ground fault circuit interrupter. So we've now added a new type of GFI that we've to the code requirements that we have. This clarifies the difference between a GFCI and a SPGFCI. Protection is required for lighting equipment, employing flexible cords that are hardwired, so on and so forth. Hey, I just said flexible cords and I thought of something. Earlier, we were talking about flexible cords and I kind of went over it real quick. I wanted you guys to understand, and I think there's a couple of code questions. So I'm going to change gears for you. I apologize for going off the rails. Let me look at the homework here. Flexible cords and cables do not fall under the same ampacity rules that everything else does. There's an exception in 2.4. It doesn't have to follow 240.4. Okay, so I'm specifically looking at 228.1 homework, questions number 6 and questions number 7. I want you guys to pay particular attention to 240.5 as well as table 400.5A1 for both of those questions. Okay? Again, the provisions of 240.4 are not applicable to flexible cords. All right? So, I am sorry I went off the rails from where I was, but I wanted to mention that before we moved on. Okay, but nonetheless, this 410.184, the code book now has clarified special purpose for ground faults. And a picture of some, I'm assuming this is basil or maybe some rosemary. Has to be. I'm just about sure of it. Oh, this looks like oregano. All right, more code changes in Article 400, Chapter 4. Article 422, appliances. Sections were identified as redundant or unnecessary have been deleted. So, as you're studying the 2020 code right now, understand that 2023 has deleted a bunch of things out of this section. Really, it's just redundancy they've removed. So you could see everything they deleted was 422.3, .4, .15, .23, .46, and .50. So you're aware of the code changes. All right, appliances identified in 422.5A1 through A7, rated 150 volts to ground or less and 60 amps or less, single or three-phase, shall now have a Class A GFCI. And as we discussed, a Class A GFCI is for protection of personnel, right? And that has a threshold of 4 to 6 milliamps versus a Class B GFCI for equipment that has a threshold of, I believe, up to 35 milliamps. Don't quote me on that one. I'm going off memory. But there's a large difference of that threshold. Speaking of which, if this is the first time you're hearing of that, be aware where you're installing that. So earlier in 2020, whenever the code changed and we had in 210.8 F specifically, people were having a hard time finding the 2-pole GFIs for the dryers and the air conditioners. And so what we actually started seeing was a whole bunch of people using the wrong type of GFI breaker in those applications. They were using Class B GFIs when they should have been using Class A. All right. So, under appliances, some of the things that we now have to GFI for sure: sump pumps, dishwashers, cord and plug connected high pressure spray wash machines, bottle fill stations, tire inflation machines, vending machines, and automotive vacuum machines. So here's an example. GFCI protection for automotive vacuum machines. 150 volts to ground and 60 amps or less must be GFCI protected. This is what we're talking about. Water coolers, bottle fill stations need to be GFCI protected. This tire inflation now has to be GFCI protected. Sump pumps not rated over 150 volts to ground and less than 60 amps must be GFCI protected. Okay, this is a storage type water heater, which is what most people have in their house unless they have an InstaHot or something of that nature. A tankless water heater. Maybe I should just say old school, because this is what people used to have. Everyone's going tankless now if they can, but either way, this used to be a question that it was on every single one of my tests: residential wireman, journeyman, master. It's buried back here in 422. They will say, I need what size what size breaker do I need for a 4500 watt water heater? Well, they would have the question worded where if you forgot the 125% rating on the water heater, because we consider it continuous use or whatever. Well, I'm assuming that's why they want 125%, but they have it worded in their question where if you don't add the multiply by 1.25, you'll get the question wrong. So the branch circuit overcurrent device and conductors for fixed storage type water heaters with a capacity of 120 gallons or less must be sized not smaller than 125% of the rating of the water heater. So the breaker has to be 125% of the water heater. Just so you are aware. That's one of those things, if you're not aware it exists, it's a real easy way to get a question wrong on a test. So think about water heaters. Think about adding 125%. Here's a good example of where we're at with that. Overcurrent device at 125. So if I said 18.75 amps is what the water heater said, I end up using a 25 amp breaker. But if I was unaware of the 125% rule, I would just answer the question as a 20 amp. See how you can get caught in that? There's a further exception, or another code. 422.11e permits you to go all the way up to 30 amps based on 150%. Okay? So, purely resistive load water heater allowed to go up to 150% in some cases. Take a look at 422.11e. All right. Flexible cord cannot be used for the connection of appliances fastened in place unless the appliance is specifically designed to be used with a flexible cord. Okay? They want that thing hardwired. There's a good illustration of what's going on there. Flexible cords and in-sync waste disposal. This is another code, little code section that's on about every test. A flexible cord is permitted for an in-sync waste disposal, and here's the kicker, 18 to 36 inches long. So, in Article 422 under appliances, there is a requirement that your disposal cannot have a cord shorter than 18 or longer than 36 inches long. Dishwasher is going to be 6 feet, right? So these are great questions that they always dig up for your journeyman's test. In addition to this, this disposal receptacle has to be accessible. It has to be a grounding type attachment plug. Can't be a 2-wire. And it has to be GFI'd in the real world too. So, supply cords to trash compactors and dishwashers that pass through a wood cabinet to be provided with protection that incorporates smooth edges. So, this is a code change because the wording in the 2020 said that it had to have a fitting, and there was no fitting listed to go through wood. So they've put smooth edges in there, something to help you go through, not a listed device to run a cord through. They've just cleaned up the wording because it was a little ambiguous in the last code cycle. All right. 422.18 is ceiling suspended paddle fans. This is another change. Okay. It's been subdivided and includes a new first level subdivision that prohibits metal parts of ceiling fans from over tub areas and shower spaces. So you can put the blades, but not the whole fan. Right? Well, if the blades aren't metal. So metal parts are prohibited over shower and tub spaces per the new 2023 code change cycle. I can't recall this being an issue in the past for me personally, but Engineer Beth here says she's happy about it. She looks happy. So, all right, cool. That's about that for all of our slides and everything that we've got going from here. So let's move on, do a little bit of homework, and see if we can go over some of this homework in the video shortly. Thanks. I'll be right back. All right, guys. Getting into the homework a little bit, just looking through this stuff. I want to talk about, let's go over the safety answers. The safety worksheet answers are as follows. Number 1 is D like dog. Number 2 is B like boy. Number 3 is C like Charlie. Number 4 is B like boy. Number 5 is A like alpha. And number 6 is C like Charlie. All right, so the reading section, we've got, 12 reading questions here. Most of that stuff is going to be, again, Article 406.12, 422.16, 408.36, 410.16, 410.116, 410.151, 404.8, 404.2, 400.10, 402.5, 406.4. So a lot of that stuff is coming out of that area. As we get into 228.1. Okay, so you'll see here's my 3 questions that we kind of went over from motors. I've already actually just given you those answers, and in all honesty, you're going to learn motors now in 3rd year rather than this year, and I thought it was kind of unfair to give you motor questions with SO chord term questions smack in the middle of 100 other questions you got to take care of this week. So I was kind of pushing on that. So this 228.1 section in itself is a little tricky. So we got the first 3 questions, right? 228.1. There we are. Motor. We already went over those. The next 2, 400.5 and 400.4, are tables for cords and cables. Then we're going to run into our protection for SO cords and cables. I want to remind you that 240.4 is not applicable to flexible cords. So for those couple of questions, that's 228.1 number 6 and 7. Right? So 6 and 7, these guys. So keep that in mind when you're answering those questions. 400.12, 414, 416, 422B. I want you to remember 400.4 table, 400.5A1, 402.5, 402.6. This is all going to be applicable to this section. There's just a lot of homework, so I'm trying to give you guys a little bit of a leg up here. So 228.3. All right, we've got a lot of luminaire questions. I mean, we got 26 different luminaire questions, all out of Article 410. So get familiar with that. That's everything from 410.10, 410.11, 410.16, 410.36, 410.154 is in there, 410.10D1, 410.30B1, and I want you to remember the exception number 2 when it comes down to some of this stuff. Number 16 looks interesting. Let's take a look at that. That's 228.3, number 16. It says a wall-mounted luminaire, such as a sconce that weighs 4 pounds, is permitted to be mounted and supported by... Okay, so whenever you go over that, I want you to keep in mind 314.27A1 exception. All right, and then I want you to look at 410.36A and see what you guys come up with. Okay? So do not forget 314.27 A1 exception and then also A2. So remember that you're going to have to leave Article 410 for those 2 questions. Again, Article 410, 151, 410.64, 410.52, 410.30. And in 410.30, like B1, exception 1 and 2, pay attention to those exceptions. 410, 154. So yeah, that whole article is straight out of a lot of 410 and 228.3. 228.4. Let's look at that. 228.4 Here we go. 228.4. Water heaters having a capacity of blank gallons or less. Right, so we kind of already talked about that one. It's going to be in Article 422, right? So all this stuff's coming out of 422. There's some things that are not, but I want you to remember your 125% rule when it comes to your water heater. Article 422 is tricky like that. GFCI protection for personnel. I mean, there's nothing really special in here. Now, let me look at this one here. 228.4, number 22. Disconnecting means and branch circuit conductors. 228.4, number 23. I'm sorry. What minimum size conductors? Because we have a couple of different code sections we're going to need for this one. What minimum size conductors required to feed a 12.5 kW 240 volt electric furnace operated at 240 volts. Size of conductors per 224.3b and the branch circuit over current protection circuit breaker that's rated for 75 degrees. So with that question, you're going to need 424.3b. You're going to need to look at 220.5b. And I want you to pay attention to 210.19a1 for that question as well. So again, that was that one was 228.4, number 23. 210. Oh, fixed electrical space heating. Those are always good. Those seem to come up on every test I've ever taken too. You need to know what percentage those are coming out of. That's something you might as well just memorize, in my opinion. It's always 125% of the connected load, but that's just something you should memorize. Look at 210.20a and 224.4b for those two, for that. But that's something, as an electrician, you should probably just have memorized. And that's pretty much it, guys. I am just experimenting, recording these things in advance. I got some ideas in mind, but really, I think that's pretty much the whole lesson. This is pretty much all code stuff. I want you to shoot me a text. Let me know this video's over. 303-968-6235. If I'm not directly watching the big blue button, shoot me a text and I'll go pay attention. I'll pop in class. This is obviously going to be a little bit early of a class, so I want to take some of our class time for you to do the homework. But I'll pop in here a minute. Just shoot me a text. Let me know that you got this. 303-968-6235. Or give me a call if you want, and we will continue on. Okay. Thanks, guys, and you'll see me live in just a few minutes. Thanks. Bye.